Now we discuss the technique of retransmission, which is used by TCP to provide a guaranteed, reliable transport service. Retransmission, what does it mean? Retransmission means that TCP initiates a retransmission of a data package in case of an error. This retransmission technique is a basic technique to ensure an error-free transmission service. And what is the idea behind this? The idea behind this is that TCP organizes sending a message, a data package, and then the receiver, as soon he receives the data package, sends back to the sender an acknowledgement. By means of this acknowledgement, TCP can find out whether transmission was done and whether the data package arrived on the receiver side in an error-free way. So the basic idea using a datagram service is that TCP guarantees error-freeness, is that TCP works with a retransmission, sending a package and waiting to get this package acknowledged. The question is how the sender knows whether the package arrived. If there is soon an incoming acknowledgement, all is fine. But assume there is a congestion inside the network and it needs a while that the data packet receives the receiver. Then the sender is waiting, and does not know whether the package got lost or whether the package received. And to have a mean to make a decision in case that data package are considered to be lost, to retransmit the package, the sender starts a so-called timer when he starts the transmission of a data packet. Then the timer is running and the sender is waiting as long as the timer is running for this acknowledgement. If the acknowledgement arrives, then all is fine. If the acknowledgement does not arrive in the time set by the timer, then this package is considered to be lost, regardless whether it's really lost or not. So by means of this timer, this retransmission can be controlled. The package is sent, timer is start, and then the package runs through the internet. The receiver receives the package, the receiver checks is it error-free, and then a receiver sends back the acknowledgement. And if the acknowledgement arrives in the time the timer runs, then the sender knows, yes, transmission worked. If there is a loss of a data package, or if there is a large delay of the data package so that the sender does not receive the acknowledgement of a data package in the time set by the timer, then the sender considers the data package as lost and retransmits this package, again starting the timer, to guarantee that the message receives, that the receiver can receive the message. To force retransmission, the receiver sends no knowledge also in case he receives the data package, but there was an error in the data. So either the data package does not arrive at the side of the receiver, or the data package arrives in a erroneous way, then no acknowledgement is sent. In this way, the sender knows exactly whether the transmission was done or not. Now let's have a closer look here to this process. Let's assume we have two, the sender and the receiver, and there is a message, one, sent to the receiver. The receiver, in the moment the message is sent, the timer is set. This is the time axis. the timer is set for a certain period of time. So the package is transmitted through the internet, package arrives at side of the receiver, and receiver sees, okay, it's error-free, and then receiver sends back an acknowledgement for this package, and the package, the acknowledgement arrived in the time span set by the timer, so sender knows the transmission of message 1 has worked. Now let's assume that message 2 is sent. Let's take another color. Message 2 is sent. So again, the timer is set. And now let's assume message got lost. Receiver is not able to send back an acknowledgement because receiver not even knows that sender has sent a new message. So receiver cannot send back an acknowledgement, and in the time the sender, in the time set by the timer, no acknowledgement receives. And this is a signal for the sender to restart transmission. So sorry, in my slide, that's the sender. We make it a little bit shorter. So in the green time span set by the timer, no acknowledgement receives, and then sender knows he has to retransmit message 2 and start retransmission, and then, or let's take another color, retransmission, starts retransmission, and now a receiver receives the message 2, sends back the acknowledgement, and acknowledgement arrives on sender side in the time span set by the timer. So the sender knows now transmission of message 2 has worked. You can see I also in the picture I was a little bit changing the time span. This is exactly a very interesting question. What is the right choice for the time limit of the timer? And to find the right limit is very much influencing the efficiency of the throughput of a network. Now we have the situation that internet is an interconnection of many different networks. So if we want to send a message inside a local area network, then we have very fast transmission speed. So a shorter time span makes sense. If we have, on the other side, a wide area connection, then it needs longer to transmit the message. And if the timer is set, the time limit is set to small, then there is no chance, even in case of a correct transmission, there is no chance to receive the acknowledgement in this short time span. So if retransmission takes place too early, then internet is flooded with superfluous duplications. Because then sender assumes data package transmission was not okay and retransmit, and retransmit and retransmit. So the network has to transport a lot of useless duplicates. In this way, the throughput decreases of the network. On the other side, if the timer is set too late, then many messages must be stored in the buffer, because then sender has to wait a long time for the acknowledgement, even if the acknowledgement arrived much earlier. There is a queue overflow. So fixed timers, this is not a right choice for the internet, because we have different situations, and a fixed timer and fixed time limits can never satisfy each situation. For that reason, we need, and TCP has implemented, a so-called adaptive retransmission. TCP has mechanisms to adjust the time limit to the situation, to the momentary situation in the network. How this is done, how does it work, this adaptive retransmission? The idea is that TCP monitors the network load. And the network load for each connection is different because the message has to run through different networks with different situations. So if TCP, there is a connection established between sender and receiver, then TCP measures the so-called round-trip time. And round-trip time is the time between sending out a message to the receiver and receiving back the acknowledgement. This is the round-trip time, the time between sending out a data packet and the arrival of the acknowledgement. This round-trip time is measured for each transmission, for every transmission, and then this round-trip time, this newly measured round-trip time, is compared with previous measurements. So TCP can find out whether there is an improvement of the network situation, that the time becomes shorter between sending out a message and receiving the acknowledgement. Or TCP can find out whether there are some problems in the network because the round-trip time is increasing. So in this way, TCP can adapt by comparing the actual round-trip time with the already measured round-trip time. TCP can adapt the speed, the time limit of the timer, and with the speed of the transmission. Of course, this is a complicated process. We will see that there are some algorithms that organizes. So the time periods, this is the main message here, the time periods are adjusted adaptively to the momentary situation, to the momentary load situation with moving average. So what we do is to consider, TCP considers a smoothed round-trip time which adapt to the actual situation of the network.